Right, ladies and gents, bit of paper two stuff. So what I'm going to do, I'm not going to, there's no kind of order to what I'm going to do here. I'm just going to go through some paper twos and stop on questions I think, right, they haven't come up in paper one. They might come up here. So I'm starting in 2019 and we'll just flick through, okay? Might be a bit of a mess like this. Right, so we need to be able to do, put things into our calculator. So the words they might use are calculate or evaluate, right? Estimate is gone, so there won't be any estimation. You're not estimating these, right? You're not changing these numbers. You are putting them into your calculator as they are. So you need to be able to just grab a calculator and put these in. So to put squared in, so you could put 4.8 and either put times 4.8 or there is a button that says x squared, which you can press to put a squared in. Plus, there is a button with a square root, and then you'll put in 28.09 equals, yeah, and away to go. Here, 4/9, again, there is a button that will allow you to put in a fraction, okay, times, right? Be careful though, because when you put 4 and 9 in there, the cursor is going to be down here next to the 9, and we need to move it over with the over arrow so that it comes back there, so that we end up with 4/9 and that the times is there, not down there with the 9, times 78.3. An alternative here, as we've done for many years now, is to divide by the bottom and times by the top. Okay, I think it might be worth talking about percentages as well. So if I wanted to do 63% of, right, the word of is times, I don't know, 87, right? Change it to a decimal and times it by 87. Or, like down here, I said divide by the bottom times by the top. Divide by 100, which finds 1%, and times by what percent you want, okay? The word reciprocal, put this in your brain, okay? The word reciprocal means 1 over. So the reciprocal of 8 is 1 over 8. So let's get that for tomorrow now. The word reciprocal means 1 over. So it's 1,000 times that. Again, you can use that button to put that in there. Now, lovely people, let me just close down some things because my computer is not enjoying a lot of things being open at the same time here. So, okay, it might be that these are linked, okay, rounding, but significant figures. So, two significant figures, first, second. So we're chopping off there. So the 4 won't change. The 3 will round up to a 4 because it's followed by a 7. But rather than just leave it as 44, it would be fine if this was a decimal number, but because we've got to add a 0 to replace that 7. Now, there is nothing wrong with adding a 0 there as well. Not a problem, but you don't need any zeros after the decimal point. You just need to make sure that they're there before to fill in gaps there, okay? Right? Done something like that. Done something like that in paper 1. Time, okay? Time. So now we'll talk about conversions, time. We're going to work in minutes, always in minutes. So 4.5 hours, okay, is 4.5 hours. So this one in minutes would be 4 times 60, not add on another 30 minutes for the half an hour. Whereas this would also be 4 times 60, but we're adding on the 45 minutes. A quarter of an hour is 15 minutes, okay? So this would be 4 times 60, but this time we're adding on a quarter of an hour, which is 15 minutes, compared to half an hour, 30 minutes, quarter of an hour, 15 minutes, or just 45 minutes. So there's different ways, but everything is changed into minutes. 1/6 of a day, well, to find 1/6 of a day, we need to take the day, which is 24 hours, and divide it by 6. So that's just 4 hours. But again, change it into minutes, times it by 60. Then you can work out which is the longest. I believe it's going to be this one. I believe it's that one, okay? Other conversions, so do anything time, work in minutes. Work in minutes. Even if the answer says give your answer in hours and minutes, just change it back at the end, okay? Longest distance, right, okay. Not really, I'm not too worried about metric conversions. Don't worry about that too much. What I'm interested in tomorrow is, in the following, right? The 1 litre is 1.75 pints. And that 1 kilogram is 2.2 pounds. Be worth knowing that, Okay. In terms of converting these, ladies and gents, right? I don't even know which one I'd go for here, but there are 10 millimeters in a centimeter. Okay, so you divide that by 10 to get into centimeters. There are 100 centimeters in a meter, so you divide that by 100 to get it into meters. And there are 1,000 meters in a kilometer, so you divide that by 1,000. My apologies, there's going to be a gap there because I just had to pause the video to deal with something there. And kind of the opposite here, then it would be times by 1,000. I don't know. I don't know what's best thing to do, right? Possibly into meters, right? That one's already in meters. If I divide that by 100, so that's 40 meters. If I times that by 1,000, so that's 2,000 plus the 70 meters. That's 2,400 times that by 1,000 as well, meters. The only one I've got then is here. Now I need to divide this one by 10 to get it into centimeters, then divide it by 100 to get it into meters. So there'd be 1, 2, 3 coming off. So that's 30 meters. So the longest distance there is 2,400 meters. Okay, but again, I'm not too worried about metric to metric like that. I'm more worried about these metric to imperial. The other one is that 1 mile is 1.6 kilometers, but they kind of did that in paper 1, right? So I wouldn't worry too much about that one. Okay. Oh, there we are. They were using it there, look. Right. So 1 kilogram is 2.2 pounds. So 1 kilogram is more than 2 pounds. So that's false because it's 2.2 pounds. I've just given you that one. Right. 7 kilometers is less than 5 miles. Well, if you times that by 1.6, you'll find that that's 8. So 7 kilometers isn't less than 8. That's false. 1 litre is less than a pint. Well, 1 litre is 1.75 pints. So actually, right, a pint is less than a metre. That's right. Yeah, that's right. So, because a litre is 1.75 pints, which is yeah, less. 1 litre. No. Yeah, it's false. Sorry, I'm just having a bit of brain there. And the other one is, ladies and gents, the other one that I haven't mentioned here, lots of conversion-y stuff, is that millilitres and centimetres cubed are the same. So 8 litres is 8,000 millilitres, which is 8,000 centimetres cubed. So is 8,000 centimetres cubed less than 900? My God, they're all false. No, dear me. Oh, I'm just having a brain. Look at that. Dear me. 7 kilometers is less than 5 miles. If 5 miles is 8 kilometers, 7 is less than 8. There we go. Forget that. Just looking for things that I'm expecting. Right. Ratio, yeah, I want a lot of ratio. Percent ratios, yeah, percentage and ratios again. So 18% of 256 with a calculator equals that. And then share that in the ratio 2 to 1. So use Adam to share in ratio. Add those 3, divide that answer by 3, and whatever that is, multiply them by 2 and multiply them by 1. Calculate the value of the largest share, so just the largest share, and round in your answer. So that's okay. Factorize in. Right, now we did there was a little bit of factorizing in paper 1. Okay, forget it though. They were harder. These are easier factorizing, single brackets. So factorizing means take things out of the brackets. So here, I'd rather actually, dear me, that's nasty. I'd rather the numbers be something like 9AB plus 12A. I don't know, right? Because then I could go, right, I can take the number 3 out because 3 goes into 9 and 12. But also there's an A in both of these, right? 3 times what makes 9? 3. The A has come outside the bracket, but the B is left. Plus 3 times what makes 12? 4. Okay. The A has come out of the bracket, so we don't need an A there. Here, we can't take a number out because 7 and 11, the biggest number that goes into 7 and 11 is 1, so forget it. So the only thing that can come out here is, surprisingly, is the A. And here, the only thing that can come out is an X. And if we take an X out of X squared, we're just left with X. If we take an X out of 8X, we're just left with 8. Expand means times. 8y minus 4 3s are 12, and y times y That one would be y squared because you're timesing a y by another y. Okay, that's expanding and factorizing single brackets. We're doing all right. We're covering quite a lot here. Yeah, there's been a bit of coordinate stuff, sorry, isn't there? Because we did that in paper 1. Now there hasn't been these, okay? Let me zoom out a little bit. Enlargement, 3 times the size. Scale factor 3, triple the size, make it 3 times as big. If we want to do this, to get this accurate, the center is 1, 2. So not only do we want it 3 times as big, we want it 3 times as far away. So to get there is 1 across, 1 up. Double it is 2 across and 2 up. Triple it is 3 across and 3 up. So start there and then make the shape 3 times as big. Okay. Worth pointing out there, lovely people, it's worth pointing out there that you could also get a translation. Remember, the top number tells you if you go right or left and how far, and the bottom number tells you if you're moving up or down. You could get a reflection. It'll give you a line, for example, y equals 2. You add that in paper 1, which line is y equals 2? So y equals 2 would be that line there. And if you flip it, you trace in paper if you want to, it flips underneath the line. Or you could get a rotation again where you'd need tracing paper, and you trace it, trace the point, put your pen there, and kind of turn the shapes. You could get those definitely. Have a look at those. They're in one of my videos last week. Nth term didn't come up. Right, so the nth term here is going up in 3s. And if I come back 3, I get positive 5, which I put in the end. Or alternatively, if they give you the nth term and say, what are the first 3 terms here? I'd go, well, 3 times 1 add 5 is 8. 3 times 2 add 5 is 11. And 3 times 3 add 5 is 14. And you can see there they are, like 8, 11, 14. But that's if they give you the answer and ask you what the sequence is. Make T the subject. Leave T by itself. In other words, magic bridge, but leave T by itself. So what is stopping T being by itself here? I'm timesing it by 3, and then I'm taking away 8. So like we were solving, the first thing we would always move is the number, and it would become R plus 8. Then we still got that T timesing by 3. The opposite of times 3 is to divide by 3. And that there actually is the final answer. So if it says make something the subject of a formula, it's a bit like solving an equation, but you're not working out and the answer is a number. You're just leaving whatever algebra you've got there. We've had something like that. Right. Okay. Okay. Dodgy way to ask it, but this is a right angle triangle. This could be Pythagoras or trig in paper 2. Okay, and I'm going to end with this question if I've got time. Yes, I'm going to end with this, and I'm going to do a second part of this and try and merge them together. Okay. Is it possible to draw a right angle triangle with these measurements? No. I wouldn't think of it like this. I'd think of it as, what would that be if this were a right angle triangle? So if this was a right angle triangle, to find the big side, it would be square, square. Let me do that for you. 12.8 squared. I'm not going to round anything here. Right, I'm going to literally write everything I can. I don't want to be rounding really until the end of each question. 8.4, that is. This one, 22.7 squared, my apologies, a bit slow here, is 515.29. If I add them together, you can be neater than me. Think about your setting up here, okay? You get 679.13, and we want to be square rooting that. So it's square, square, add, square root. So if I square root that, I get 26.1. They have written 25.6, so they are wrong. So this is not a right angle triangle. If this was a right angle triangle, that would be 26.1. So just remember for Pythag, that's a funny way of asking it. If you're trying to find the big side, it's square, square, add your answers together and square root. However, if they'd given you the 25.6 in this and basically said, well, work that one out there, then it's square, square, subtract, square root. Now, part 2 of this video is going to have a bit of trig, trial and improvement, maybe estimated mean, and any other bits and bobs I can think of.